virtualization, earlier when we were talking to the customers or in industry, virtualization was strictly no-no, or people were yet to feel that virtualization would be reality. But things have changed over a period of time, and as you see, the adoption of virtualization has been growing year and year. I mean, right from 2005 to 2013, you can see a drastic improvement or adoption of virtualization. And this has been predicted that virtualization penetration would be 80% in the market, meaning we would have in any infrastructure, 80% of their workloads, the servers would be virtualized. So as we move on, right, what's the IT service level, or how can IT leverage more out of less? That's very much important. So what we see here is there is a three-phase-wise approach. The phase one is do the IT production. So virtualize your production servers or virtualize your less critical production servers in a VMware or a vSphere world. Then you virtualize the phase two is virtualize the production business critical apps, the business production servers on the vSphere platform. However, that's not where we stop. So IT has to be agile. IT has to do more out of less, as I said. So IT has to be providing infrastructure as services for the customers or for the internal LOBs, the line of business, right? So as we see, there is average three-phase average VM for the admins to go through from the production to the business production and moving on to infrastructure as a service. So VMware came up with the concept. We in fact coined the industry term called as software-defined data center. So VMware came up with the concept of having a single layer for the data center, that is software, meaning the software would rule the data center. So in the data center, the major components that we have is the compute power, that is CPU memory. Then we already virtualized that, right? The other component that we have is the storage component. Then we have the networks. So why not virtualize that? Why not bring that in a virtualized world so that the provisioning or the lead time of the VM decreases? So we came up with the concept of software-defined data center, and what we believe is abstract, pool, and automate. So basically, we applied the concept or we applied the whole theory for the entire data center. Abstract means take out the resources which are available within the cluster, make a pool of those resources, and make a complete automation out of these resources, right from provisioning the VM to right from the VM life cycle. So we are going to see this in next few slides, how this theory applies for abstract, pool, and automate. So as we said, the fundamental or the foundation architecture is the software would rule the data center. So virtualize your entire infrastructure, deliver it as a IT as a service, the third phase, and automate it through software. So you have all your rules, you have your all management in place, so that when you want to provision a VM, it's not a matter of days, it's a matter of minutes. So that is where the architectural foundation has to be abstract, pool, and automate. The software-defined data center, I already spoke about this. I spoke the data center consists of compute, which we already did. Then it consists of storage. Then it consists of networks and the management tools. So these are the four major points that by large we would find it in any data center. The compute, the storage, the network, and how do I apply the automation on top of all these four elements. So let's get little bit into the compute part of it. Let's understand what do we mean when we talk about software-defined data center and the compute part and how it applies in the reality. So when we talk about the compute part, we have seen that the market research shows that the number of Unix server, the number of Unix server being sold or the number of Unix servers being adopted has been declining over a period of time, and the x86 penetration has been increasing. So I would leave this slide here for you to read. However, what it says is the x86 penetration is increasing in the market, right? So the Intel-based penetration is increasing in the market, and the Unix server is declining. So what this gives the opportunity for us or for all of us is, why not leverage the virtualization technology so that I don't increase my compute power, or so that I don't increase my footprint into a data center by adding multiple servers for just one app. So that is where the opportunity lies for each one of us to think from the server virtualization or a compute virtualization. And whilst we say that we can virtualize, or we can have the compute virtualized in a data center, we can say that we can also virtualize your mission critical apps, the business critical apps. We have functionalities today wherein there is the high availability option available for the applications. What does this mean? Well, very simple. If there is an application which has a problem, we all know what happens, right? I mean, if it is for example, if it is a SQL application, the best way that we do is probably restart the service once. The second option that we do is again restart the service, and the third option that we adopt is probably go ahead and restart the server, right? So these are the common things that we follow. But who will do this? I mean, who will say that there is a problem in application? Who will say that the service has hung, right? So in a virtualized world, on a VMware virtualized world or on a vSphere, the vSphere understands the application services as well. So if there is any problem, it will go ahead and reboot the services, and it would ensure that you have high availability, or it will ensure that you meet the business SLAs. Same thing is on the business critical applications, right? So recently we did a few surveys, and it is found that nearly about 80% of x86 applications are today virtualized on a VMware platform. So be it Exchange, be it SharePoint, be it SAP, or be it your AD, all these applications are today primarily virtualized on a VMware platform. So, as I said, the applications love vSphere because they know that they will have the high availability, they will have the HA functionality inbuilt for the application today from VMware vSphere. I'm sure all of you have seen this jargons, and we have been seeing this in a very day-to-day life now. Cloud, big data extension. These are some of the big jargons which we have seen in the today's world or in the next generation applications. So VMware vSphere is not just compatible, or is not just hosting today the business critical workloads, or does not have the capability to just host the business critical workloads like SAP, Oracle, Java. We also have the application best performance for the cloud or the Python or the Java Springfield, the development platform, right? So it cut across all the technologies. That's the beauty of VMware vSphere, which is the foundation for your software-defined data center in any organization. So to recap, we saw the compute power or the CPU and the memory is something which we have been doing over a decade now. We have improved a lot by including features like app-aware HA, hosting the large capacity VMs, and hosting the business critical applications. So over a period of time, VMware has evolved the compute virtualization very strongly, and on a very confident note, as we said, 80% of world's 836 applications are today virtualized on a VMware platform. Coming on to the storage part, this is something which is really crucial, right? Because at the end of the day, what resides or the data, the VMware file or the VMDK or the VM file is nothing but a file that is residing on your storage. So the storage also plays a very important key role in a software-defined data center when we talk about virtualization or the complete virtualization of your data center. So on top of the vSphere, we built a layer for software-defined storage, and let's go ahead and see. I'm sure earlier all of you have heard about the storages, the external storages, right? The SAN or the NAS box or whatever you might be, FCOE, you might be using. So what we did on the vSphere part is we opened up the APIs for the storage vendors like EMC, and we'll have a slide over it, but we opened up the APIs for the storage vendors like EMC, NetApp, Dell, so that they can go ahead and build a layer, or they can go ahead and build the layer for the storage virtualization on top of the vSphere or top of the hypervisor, right? And as you see, some of the things which I'm sure you are already aware about, storage vMotion, right? When there is a problem on a storage from an IOPS perspective or from a latency perspective, the storage vMotion would kick in, or you can have storage DRS to kick in. Or if you want to take a downtime of the storage, you can move the VMDKs online. You don't have to take the VM offline or power off the VM and do it. Same thing is with VAAI, right? So on the VAAI is the VMware vSphere adapter for storage integration, wherein the provisioning, or whenever you are doing the VDI, or whenever you are doing the virtual desktop infrastructure environment, the provisioning of the storage or the provisioning of the VMs happens locally over a hypervisor. How? We would see that the hypervisor sends the command to the storage, and the provisioning happens locally on the storage side from the hypervisor, right? So that's how the integration is there between the vSphere and the storage, software-defined storage. So these are some of the enhancements. Also, we did some great enhancement from integration of VMware vSphere vFlash. So what is this vFlash? Well, we all know that there are read IOPS and there are write IOPS. So what we can do in a software-defined data center or in a storage side from virtualization perspective is the most common high read requests which are there. The read requests which are there, those get cached on the local side of the hardware or on the server side, right? So you take a pool of hard disks from the servers, you create a pool of hard disks on the servers, and then you create it as a flash memory for all your VMs for the read IOPS. Well, what happens in this? Obviously, when there is a cache for my read, the read performance will be faster, right? So that is where the vSphere vFlash was integrated as part of the storage enhancement. We also, we are going to talk more on the virtual SAN and the Varisto in the coming slides. But we also built the virtual SANs for enterprise segment also. I'm sure you must have heard about VSA earlier, the VMware Storage Appliance, right? So VMware Storage Appliance, for those who may have not heard, was part for offering for the SMB, the small and the medium business segment, right? Taking the same concept, same logic ahead, we built the virtual SAN, and I'm not going to talk virtual SAN right now because I have a dedicated slide on it. But what I'm saying is we reinvented, we redefined rather, not reinvented, sorry. We redefined the technology for the VSA, and on top of that we built virtual SAN. So VSA was something like whenever we used to go, the customers from the SMB segment used to complain saying that I cannot afford an external storage, right? External storage is very costly. This is something which we really cannot look at. So what we did is we said, okay, sir, fine. You have a hard disk pool. These hard disk pool are part of your vSphere cluster. So we will leverage the internal hard disk pool, and we will also give you fault tolerance. We can build a layer, a RAID 5. We can build a RAID 6 or a RAID 10, right? So what happens here is we all know that the internal hard disks are much cheaper than the external hard disks or the external storages, right? So we leveraged that and we created a pool for the SMB segment, which is called as VMware Storage Appliance, VSA. So using the same technology, we built vSAN as a part of software-defined storage. So vSAN, right? What is this vSAN? Well, if I have to simply put it in a simple way, in the VSA or the virtual storage appliance, we were using the internal hard disk of all the internal servers or all the servers. There was no criteria because since that solution was built for the SMB, the internal hard disk could be SAS or SATA or whatever, right? There was no criteria that the internal hard disk has to be SSD, right? So what we did is we said that for the virtual SAN or for the vSAN, we need the internal hard disk in the cluster to be SSD. At least one hard disk between the cluster of the host has to be SSD hard disk, right? So that is where we just did the enhancement. Why did we do this enhancement? Because we are building this solution for the enterprise class customers, right? So that is where we said we use the same technology, and right now what we are offering is we can have such 8 hosts in one cluster, meaning 8 physical hosts with one cluster with 5 hard disks each, right? With the 5 hard disks each on 8 hosts, we can build a complete storage pool. And what we can do or what we can scale up to, we can scale it up to 32 physical hosts in a cluster with 5 physical hard disks. So you can imagine what kind of savings, it's going to be humongous savings that we are talking about from buying the external storage. And we are also talking about automating that storage by doing a storage tiering, right? So that is where the vSAN. So this is where it shows you the clear pictorial view how the virtual storage appliance is going to look like. And what we offer here is also a complete resilient architecture. So as you see here, there is a hard disk which resides, there is a copy which gets stored, a mirrored copy or a fault tolerant copy that gets stored, and as you see, it gets written there, it gets cached, and it goes back to the VM. So there is always a copy maintained. Now why? Let's say there is a hard disk that fails, right? Look at this. There is again a fault tolerant copy that is maintained. The pointer gets changed. It understands, oh, okay, this is my new copy. I go there and it is in complete sync. So that is where we said the vSAN becomes like a true virtualized storage environment for any enterprise class customer. I'm not going to read out all the points, but obviously when I have, we can always leverage the existing internal hard disk or the external storage also if you have those, but there is no need to have an external storage when you start looking at leveraging the internal hard disk. And time to provision is definitely going to reduce, right? So these are some of the key benefits of virtual SAN that would deliver. we spoke about the partner ecosystem in a brief. We said that, we have a strong partner ecosystem right from NetApp, Dell, EMC, and we opened up our APIs for them so that they can build a strong platform for the storage virtualization, right? So one of the key things what we also got out of this or out of this partnership is the profile-driven control panel, meaning right now from the vSphere, the VM case or the VM placement can be decided, right? So, and you can also have within the vSphere, you don't have to go ahead and open different panes to control your storage. You can integrate your storages or you can manage your storages using your VMware vSphere vCenter client, right? So that's again a big benefit that gives to the customers. Excuse me. That's again the big benefit that gives to the customers, that it reduces the number of windows that you need to manage that you need to use to manage your virtualized environment. Moving on. Network. All right. So we touched base upon the compute, which we have been doing for years now. We saw on the storage, the vSAN revolution that we brought in. We had VSA, we leveraged that technology, the vSAN revolution that we brought in, and the benefits that it has today in a network or in a storage environment. So, and the savings that it can bring for any enterprise class customer or a mid-sized business class customer as well. There's no need of having an external storage. So coming on to the network, right? Network has been really, a concern for most of the customers in a virtualized environment. Well, say why? Because if I have to provision a VM, right? Let's say if I have to provision a VM, I have a template, I have to provision it, still it would take all these other components which are there, the switch, the router, the firewall, the load balancer. These are different teams, you need to go and talk to them, get those things done. So even if I have to provision a VM, set up the rules, all these dependencies, the conventional networking approach which is there was a barrier for IT agility, right? The IT would say, okay, I am virtualized, I have done the virtualization, but look what, if I have to get the VM up and running, I need a network, I need an IP address, I need to know in which DMZ this has to be placed, or whether it has to be placed in DMZ or not. What is the firewall settings? All this is a complete setback or a barrier for your software-defined data center, because as I said at the start of the conversation, at the start of the call, the software-defined data center, meaning the software will rule your data center and the software will manage the entire data center. So the network was completely, tightly coupled to the traditional way in the earlier days. So I'll spend a minute or so here before we actually get into the nitty-gritties of the NSX or the network virtualization. So what VMware did in the past is around, let's say, 1.5 year back time frame, right? We acquired a company called Nigeria. So Nigeria, and this was a huge acquisition for VMware because we spent nearly about 1.2 billion, which was almost a pretty good, decent amount to acquire a company, and 25% of our cash reserves, rather, to simply put, right? So we acquired this company, Nigeria, and Nigeria's bread and butter was to provide network virtualization. But who was Nigeria catering? Nigeria used to cater to the likes of Rackspace, NASA, or giant customers, right? So where you have huge server farm, who use routers, switches, you need different rules. So we took that company and we said, okay, and we acquired the company and we said, okay, what can we do with it? What is that we can do with the network virtualization? So we got in the VCNS. I'm sure most of you must have heard about this term, VCNS, the VMware Cloud Networking Services, right? So we got the VMware Cloud Networking Services, for the private cloud. But what about if there is a hybrid cloud environment? What about that if the customer wants to run the workloads between the private cloud and the public cloud, which is hybrid cloud, and I need to move my workloads? Do I every time need to change the configurations of the VM, or do I have a single identity for the VM, right? So that is where we said, okay, VCNS or the VMware vCloud Networking Services is fine for the private cloud environment. We need something as robust as NSX for the public cloud or the hybrid cloud kind of environment. And that is where the NSX technology or the NSX was evolved from VMware. So I'll quote another example so that it makes very easier for you guys to understand, because next few slides are just going to be the pictorial slides and it's more from how it works and blah blah blah. But I want to make the technology look very simple for you so that you understand what this is all about. I mean, is this is this just something which is really possible to happen? Or is this something which is like, okay, we are talking 10,000 feet above the sea level? So I'll give another example, just to give an analogy or just to correlate the exact scenario, the private cloud, public cloud, and the workloads running between private, public, and that is something which is called as the hybrid cloud. So in our earlier world, I had a friend, a friend from my college, and whenever I had to call him, when I was in the college days, I had to call him on his landline, right? So whether he is in his own house, I have to call the telephone landline number. I have to dial the prefix 022 blah blah blah, and call him on his landline. And then whenever he used to go out for tuitions or wherever, I had to again call him on his landline, but a different identity. I had to call him on his tuition search landline number, right? So as we grew and as the mobile technology evolved in India, right? Today whenever I have to reach my friend, right? I don't have to call him anymore on a different identities, right? What I do is I just know one single number, 98203, whatever, 10-digit number which is there, and I just reach him. So now whether he is in office, whether he is in market, or whether he is in cinema theater, right? Doesn't matter. Identity is single. If I want to reach my friend Ranjit, I just call him on one particular number and I'm able to reach him, whether he is in India or whether he is out of India. If he has got ISC enabled, even if he travels out of India, identity is simple. One single number, and I know I'm calling this person. Earlier, the identity used to change every time. As I said, when he is at home, Ranjit's residence, when he is at tuition, or when he is at school or college, I have to call on a different identities. So I hope I was able to give you the correlation. So VMs would change. So does that mean the identity or the underlying networking configuration should change for VM? The firewall rules should change for the VM? Well, no, not at all. So that is what is all about when we talk about network virtualization or NSX, right? So operational mode for the VM, L2, L3, switches, firewall, load balancers, right? So the application dependencies of the network, different applications, whether it's web, app or DB, they have different dependencies, right, from L2 switch to load balancers. So we virtualized all this concept, or we virtualized all this network requirement as a virtual appliance, which is NSX. So this is the common terminology when we switch into the virtualization. the VM communication from hypervisor to hypervisor or from one host to another host goes through from one switch to another switch, right? So depending on how you have configured your networking, you see it reaches there. And look, hypervisor with NSX, what happens? If I have to talk to a particular VM outside or on another switch, it's the same traditional, but if I have to talk to a VM on the same hypervisor, it will go locally, meaning the packets will not flow out of your server. It will just stay on your server. So you don't have to hit the switch and come back. All this is taken care when NSX. So you have a appliance set up in your vSphere environment, and the routing becomes much easier, complete software-defined data center or in a virtualized data center, 100% virtualized data center. So even for the matter of security, as we see how it is with NSX, let's see. If you see, everything is on the hypervisor side. You no longer have to depend externally. Load balancing also on the hypervisor. So what does this mean? I mean, I'm sure you saw this slide before, meaning the vSphere administrator, or it may not be a vSphere administrator also, it might be a network or a firewall guy itself, but everything is from the software side and everything is on the hypervisor side. So, you open one single dashboard or a console and you manage your complete virtual infrastructure. I don't have to go and open different consoles, routing, switches, nothing. I do it in a one console, and it's not about just opening console and doing it. It's not about just that. It's about also creating a single identity. It's all about doing the routing. It's all about doing the load balancing, and the efficient way of flowing the packets. So everything is taken care. So instead of provisioning from minutes, instead of provisioning from days, your VM provisioning comes to minutes. Obviously, when I have a complete control over my entire provisioning of the VM, it's going to be much easier. So that's the beauty of NSX for any customers or for the enterprise class customers, wherein you virtualize the network layer also, you improve the routing, right, the switching or the routing, and on top of that you have the power of load balancers, firewalls, you can have high availability load balancers. All this is completely possible, and the huge benefit that we see here is any hardware firewall or any firewall which is like a hardware appliance, it has got a limitation. It has got a 3-year, 4-year or 5-year. After a certain time, you have to replace the hardware. When you have a virtualized firewall, a virtualized switch, a virtualized load balancer, guess what? Obviously, it's going to be hosted on a physical hardware, but guess what? The configuration is there. I mean, there is no hardware, there is no hardware refresh. The only hardware refresh that you are doing is on the underlying compute power, which any organization has from a 3 to 5 years. So at least your hardware refresh of your network layer is also been decoupled or has been taken out from your environment. So that's again another advantage that network virtualization today can bring to any organization. Finally, on the automation, so as I said, whilst we are been doing great or fantastic things from the virtualization technology, right from the compute to storage to network, to manage this you need an intelligent automation software, or you need an intelligent automation system in place. So the next few slides you're going to see, what this automation means. Where automation means how is my environment performing? How is my vSphere, or how is my other servers performing? Right? It is also about having the complete automation control in a single pane of control, right? So that is something which is very, very important when we talk about the automation part. So this is the pictorial way. So it is a very intuitive. So let's say you have the user, and the users want to provision the users want to provision the VMs or the machines for themselves. You have workflows. So let's say I am a test-based user and I want a Windows machine with Windows Server 2012, with SQL Server 2012, and blah 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 softwares loaded. Why do I have to go to IT? We can build a workflow, wherein the user will raise a request. The request will be directed to his or her manager. The manager approves or disapproves the configuration of the machine, and depending on the business case, and the machine gets provisioned for the VM. If it is declined, it gets declined, and the user is given an intimation why the request has been declined. So what happens here is IT becomes enabler. IT can still keep control, but the overhead or the unwanted overhead is being removed from the IT, or the IT becomes more agile again to work on more innovative things. So as you see, this is just a pictorial view wherein it gives about the dashboard, how many machines the person would be running, how many are pending requests, how many machines have stopped, all that stuff. So you know how many machines at any given point of time the user is running. Furthermore, as you see there, this is something which is very, very crucial. You can put the entire cost of running your virtual machine. So whether it is a test environment or whether it is a production environment. So I'll give a simple example. It might look like, oh, what is this cost about? Why do I need to really put cost and do what? Right? I'm sure most of you will agree that when budgets are given to IT, being shrunk, meaning IT has to really fight for budgets, because what it feels is IT is taking up all my budgets. But the fact is, we don't go ahead and purchase things for our own self, right? IT will be purchasing storage, IT will be purchasing servers, IT will be purchasing certain software, networks, whatever. And why is IT doing all this purchase? Well, simple, because it has to give the services to the business, right? So if I have different businesses like sales, marketing, blah, 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 development, whatever, right? And I can say, okay, look, sales for you, or these are the common machines which have been running across all the LOBs, but for sales, this is something which is your app, your HR, this is something which is your app, finance, payroll, this is your app, and these are the servers that are being consumed, and this is the cost which has been incurred over a period of years. So we are just the facilitators here, right? So giving out those facts during the budget discussion makes much simpler. So for the benefit of time, I'm not getting into much nitty-gritties here, but it really helps the IT to automate, or it really helps IT to understand where the cost is incurred and to take back the cost from the respective businesses. The same thing is with the requesting the virtual machines. The user can decide how much memory, how much CPUs. It gives the complete power of choice to the end user. And then you see a complete chart like you see in a vending machine, right? If I need to take a Coke, I have to pay maybe 40 rupees a tin. Or if I have to take a Cadbury bar, I have to pay 10 rupees. And so on and so forth. You know what it is. And you can customize and see what is required. So same thing is here. The app server, IaaS server, SQL server, whatever I'm going to consume, it's something which is having a cost, and that is something which will be recorded back or charged back to the organization. And you can see how many machines. The user can itself see how many machines are there. So as I said, this gives a complete power of choice and transparency to the end user. I mean, nobody can say that IT is demanding money. IT is requiring money because IT has to facilitate our requirements. That is where you become transparent in pricing and governance. Same thing is on the operations management. I'll spend a minute here, and this is very interesting, right? And rest are all the slides which you will definitely follow. What happens if there is a problem in an application, right? What happens? Normally, the storage guy would say, hey, it's not a storage problem. Network guy would say, it's not a network problem. Compute or a VMware administrator would say, it's not our problem. Everything, the server is hardly utilized, 10% utilized CPU, 5% memory utilized. Our is and it is my problem. You keep on running round and round and round to figure out who is really having or who is really answerable for this problem. Sometimes it becomes that, it becomes very, very tedious and it takes time to figure out where the problem was, or sometimes the problem dies its own death. Depends, right? Different companies, different scenarios. But wouldn't it be nice to get an insight on a complete dashboard in terms of how the environment is performing? So that is where the operations management or the VMware solutions play a key role in the automation as well. So the key example here, it solves or it gives you a complete overview, health, risk, efficiency. How is my vSphere environment performing? And as all of us know, on a scale of 1 to 100, health, the more it is towards 100, the better it is. The risk, the lower the risk, the better it is. The efficiency, the more to the 100, the better it is. So what is health? So health is nothing but how is your current environment performing? The CPU, the network, the storage. Are there any latencies? Are there any problems? Risk. If I have been provisioning VMs, let's say for example, hypothetical example, I have a 128 GB server and I have been provisioning VMs of 16 GB each. So over a period of time, so if I provision same such VMs in next 7 days or 8 days, I'm going to run out of the VM capacity on the server or on the server pool. So that's the risk. So who will intimate IT or who will give the heads up? So that is where it comes in a singular dashboard. Efficiency, right? Efficiency is, all know the common idea or the common concept in any organization is, hey, you know what? The application vendor has said, give me 40 GB space or whatever space, give me 96 GB RAM. Yet this is a very resource consuming application, so we cannot take any risk of having problems on the application. But over a period of 6 months, 1 year, we figure out, look what, your memory utilization is never over 20, 30, 40% or 50%. So whilst you can scale it down to maybe, if you have given 96 GB RAM, you can scale it down to 64 GB, not at least 48 GB, but that's saving. That's automation. That is keeping things very simple, right? And doing the cost saving for the organizations. That is the automation based on the policy. The high level dashboard, where is the problem right now? Otherwise it all becomes like a guesswork for the users. Which VMs? Which are undersized VM? Which are oversized VM? A complete pictorial view in a click of mouse. The complete environment, whether it's a vCenter server, data centers, clusters, hosts, VMs, you have a complete correlation. You can see what was the event, what was the event source, and what was the problem. So it will also give you a RCA, root cause analysis. So I have a slide here which will talk about it. It will talk about the root cause analysis, what had happened. It also talks about the count of idle, powered off, and oversized VM per ESX host. If the VM has been powered off from last 140 days or 100 days, I really need to keep that VM on or off, or how many VMs are such which are powered off? Because even if the VM is powered off, it is consuming the space over your storage. Whether it is external or internal, it is consuming some hard disk space. It's always better that if I clean up unwanted VMs. So that is what the intelligence comes out of the automation. And there are several of other reports inbuilt within the automation capability, wherein you can just go and pull out the report and learn what's wrong in your organization or in a virtualized environment or in a software-defined data center yourself. You don't have to be dependent on the storage guy. You don't have to be dependent on the network guy. Hey, is there a problem in network? Wait, I know if there is a problem in network. This is the report. This is what it says. Right. So that is the beauty of analytics. And the other part, this is the last slide over here, but the other part, what it says on the analytics part, I would really like to spend a minute on that. I'll give a simple analogy, right? Most of the management solutions just go by the symptoms or just go by, bare minimum analogy. There is no self-learning pattern or, there is no self-learning analytics. I'll give an example here, slightly vague, but it applies here. Let's say, if a person is sitting in living room in a AC, and on a Sunday afternoon he is watching a good movie, right? Watching a movie, sitting under AC, and he starts sweating, right? So there is a problem. They rush him to a hospital because there is something abnormal, right? But the same person, again, is in the gym and he is in the AC gym and he's sweating, working on a treadmill. He's sweating. But is that a problem? I mean, the AC is there, the person is the same, he's sweating, but can you rush a person to a gym unnecessarily when he's working out? Because so what I'm trying to say is the traditional tools just look at the problem as sweating and throw alerts or intimidate the users, while the operations management or the automation has self-learning analytics. So if I have to sum it up in a single way, there could be a payroll application which would go high on utilization at a month end between 20th to 25th of every month. And it might be hosted on a SQL DB or whatever SAP or whatever application or Oracle or whatever. But if that's a pattern, because payroll is processing the salary or payroll is processing the records, right? So between 20th to 25th of every month, that's a pattern for this server. I don't need to throw an alert. So that's where the automation or the intelligent analytics will come in play to completely define your software-defined data center. As I said, to sum it up, you can build your software-defined data center brick by brick. So there are various offerings which we have to start with. You can start with the standard edition and you can leverage the Enterprise Plus class features, which are, which is the high-end edition of VMware vSphere. And then you can start building your brick by brick by moving on to advanced to the vCloud Suite Enterprise. So with that, thank you all and have a wonderful evening ahead. Take care. Bye-bye.